Hello everyone, in this video we're going to explore topic 7.1 modeling situations with differential equations. A solution to a differential equation is a function that satisfies the differential equation when the function and its derivatives are substituted into the equation. A solution to a differential equation could be one function that's called singular solution, or a set of functions which is general solution. Alright, example of differential equations: y double prime plus 2y prime equals 3y. F double prime of s plus 2f prime of s equals 3 times f of s. D squared y over dx squared plus 2 dy over dx equals 3y. Now, recall, direct variation occurs when a situation gives rise to a linear function f of s equals k times s, or y equals k times s, where k is the variation constant, or constant of proportionality. We can say y varies directly as s, or y is directly proportional to s. Now, inverse variation occurs when a situation gives rise to a function f of s equals k over s, or y equals k over s, or k equals s times y, where k is the constant of proportionality. We can say y varies inversely as s, or y is inversely proportional to s. Alright, let's take a look at the example right here. A particle moves along a straight line. Its velocity v is inversely proportional to the square of the distance as it has traveled. Which equation describes the relationship? Alright, now the keywords right here is inversely proportional. Alright, so we're going to apply the formula right here. Alright, so we have the velocity is v equals the constant k divided by the square of the distance. Alright, so it's going to be s squared. Alright, so the answer must be b. Now, example number 2, a puppy gains weight w at a rate. Alright, it tells us that this one is w prime, approximately inversely proportional. Alright, so it's going to be equals constant of proportionality k divided by its ht. Or you can write dw over dt equals k over t. Now, example number 3, the learning rate for a skill S is proportional to the difference between the maximum potential for learning that skill M and the amount of that skill already learned L. Write an equation that describes the relationship. Alright, now again, the learning rate, whenever we talk about rate, we talk about the first derivative, right? So it could be s prime is proportional, right? So which means equals constant of proportional k multiplied by the difference, which means subtraction, right? Between the maximum is going to be m. Subtract and the amount that still already learned L, so subtract L, right? Or you can write this as over dt equals k times m subtract L, right? Now, example number 4, Unfortunate administers medication to a patient's bloodstream at a rate of 3 cubic centimeters per hour. At the same time, the patient organs remove the medication from the patient bloodstream at a rate proportional to the current volume V of the medication in the bloodstream. Which equation describes the relationship? We have dV over dt equals I look at a rate of 3 cubic centimeters per hour, so it could be 3, right? At the same time, the patient organs remove, the medication remove, which means subtract from the patient's bloodstream at a rate proportional, so it could be K time to the current volume, which means V, right? So the answer must be A. Now example number 5. A chemical is diluted out of a tank by pumping pool water into the tank and pumping the existing solution out of it. So the volume at any time t is 20 plus 2t. The amount E of chemical in the tank decreases at a rate proportional to the Z and inversely proportional to the volume of the solution in the tank. Which equation describes this relationship? Alright, so you have Z prime, right? Decreases, which means subtraction, right? At a rate proportional to Z, right? So it could be K times Z. And inversely, right? So divide by proportional to the volume, right? So it could be 20 plus 2t, right? The volume right here. Then the answer is A, right? Because C prime is actually dc over dt. We're going to explore topic 7.2, verifying solution to differential equations. Example number 1. Determine whether the given function is a solution to a differential equation f the program of s minus f of s equals 0, right? So you given f of s equals sine s, then you're going to take the first derivative f of s. It's going to be cosine of s, right? And then you're going to take the second derivative. It turns out to be negative sine of s, right? Now, we're going to substitute this guy and this guy into the equation right here. F the program of s equals negative sine s, right? Minus f of s equals sine s right here, right? And then you're going to simplify, it could be negative 2 sine s, which is not equals to 0, right? We need 0 right here. So you're going to say that f of s equals sine s is not a solution to a differential equation. Alright, let's move on to question B. You have f prime of s equals, you have e to the u derivative. It could be u prime times e to the u, right? In this situation, use is negative s, right? Alright, so this guy turns out to be negative 4 e to the negative s, right? Then f the program of s is going to be 4 times e to the negative s, right? Now you're going to substitute f of s and f the program of s into this equation, right? So you have 4 times e to the negative s minus 4 times e to the negative s equals 0, right? So you're going to say that f of s is 4 e to the negative s is a solution to the differential equation, right? Differential equation, I just write dE, right? On the ABC, you need to write this one down, okay? Now question C, f of s equals c times e to the s, where c is a constant, right? So I have f prime of s equals c times e to the s, right? And f the program of s is still c times e to the s, right? Now you substitute f(s) equals c times e to the s and f double prime of s equals c times e to the s into this equation, right? So it could be c times e to the s minus c times e to the s. It could be 0. So you're going to say yes. f(s) equals c times e to the s is a solution to the differential equation. Now let's move on to example number 2. Determine whether the given function is a solution to the differential equation dy over ds equals 4y over s. Question A right here, you need to take derivative both sides with respect to s, right? So I have dy over ds equals 4, right? Now I'm gonna substitute for this one over here, right? So I have 4 equals 4y over s, but y equals 4s, right? So this guy turns out to be 4 equals 4 times 4s over s, right? So it could be 16, right? Now 4 different from 16, right? So then you say no, y equals 4s is not a solution to the differential equation right here, right? Now question B, you're going to take derivative both sides with respect to s, so I have dy over ds equals 4s cubed, right? Now I need to substitute this guy over here, so I have 4s cubed equals 4 over s times y, but y equals this one, so times s power 4, right? Now I need to simplify 4s cubed equals 4 s to the 4 divided by s could be s cubed, right? So this one, yes. Y equals s to the 4 is a solution to the differential equation right here, right? Now, example number 3. For what value of k, if any, is y equal e to the 2s plus k times e to the negative 3s is a solution to the differential equation for y minus y double prime equals 10 times e to the negative 3s. Alright. So observe that you have y double prime here, so you need to take the second derivative of this one, right? So I have y prime equals 2 times e to the 2s minus 3k times e to the negative 3s, right? Now y double prime is going to be 4 times e to the 2s plus 9 times k times e to the negative 3s, right? Now I substitute y double prime and y right here into this differential equation, right? So I have 4 times y, which means times e raised to the 2s plus k times e raised to the negative 3s, right? Minus y double prime, which is 4 times e to the 2s, don't forget parentheses, plus 9 times k times e to the negative 3s, right? Equals 10 times e to the negative 3s. Now I'm going to distribute this one, so it could be 4 e to the 2s plus 4k times e to the negative 3s, right? Now I distribute negative 1, so it will be negative 4 times e to the 2s minus 9k e to the negative 3s equals 10 times e to the negative 3s, right? Now this guy and this guy cancel out, right? 4 subtract 9 is going to be negative 5k e to the negative 3s equals 10 times e to the negative 3s, right? Now both sides have e to the negative 3s. You need to cancel out, right? So I have negative 5k equals 10, and then k equals negative 2. So the answer must be A. We're going to explore topic 7.3 and 7.4 slope fields. In later lesson, we will learn ways to solve a differential equation analytically. However, doing so can be difficult or sometimes impossible. A practical approach to solve a differential equation is by creating slope fields, which show the general shape of all solutions to a differential equation. Consider a differential equation y prime equals capital F of s, y in terms of s and y for every point s and y in its domain. Y prime determines the slope of the solution function at that point. If you draw a short line segment with the slope indicated at each point on the y prime slope field or direction field, will show the general shape of all solution functions to that differential equation. Now let's take a look at example number 1. Consider the following differential equation: dy over ds equals negative s over 2y. Sketch a slope field of the differential equation on the coordinate plane. Alright, so this one is the y, this one is the s, right? Now, in order to do this one, you need to sketch a T-shape, right? Now, remember, we have the Christmas tree trick. Alright, if the tangent lines go in this way, the slope is positive. If the tangent lines go in this way, the slope is negative. If the tangent line is horizontal, the slope is 0. If the tangent line is vertical, the slope is undefined. Now for this line, the bigger slope, the steeper tangent line. Now for this one, the smaller slope, the steeper tangent line. Now we're going to start from this point, s equals negative 2, y equals 2. Then we substitute over here. Alright, so dy over ds equals 1/2, right? So does that mean rise equals 1, run equals 2, right? So you go up by 1, go to the right by 2, right? So you're going to connect this guy and this guy. So the tangent line should be something like this. Now, right at this point, s equals negative 1, y equals 2, it's going to be 1 over 4, right? 1 over 4 is less than 1/2, so it's going to be less steep, right? So does that mean you need to go up by 1, go to the right by 4, 1, 2, 3, and 4 right here. So if you connect this guy and this guy, so it's going to be something like this. For this one right here, s equals 0, y equals 2. It's going to be 0. Now you look at the Christmas tree trick right here. It should be horizontal, so it could be like this. Alright, now s equals 1, y equals 2. Substitute over here, it's going to be negative 1 over 4, right? And s equals 2, y equals 2. It should be negative 1/2, right? Now negative 1/2 is less than negative 1/4, right? So right here it's going to be steeper, and it's going to be less steep right here. So based on my instruction, go ahead, pause the video and finish the rest. Alright, so here's the complete slope field of the differential equation. Alright, right at these points right here, the derivative is undefined. Why? Because y equals 0, right? So when you substitute over here, it's going to be undefined, right? So whenever the denominator of the differential equation equals 0, we're not going to draw a slope segment. This is because the derivative is not defined at those points. we cannot necessarily guarantee why the derivative is undefined. Right. B. Sketch a possible solution curve to the differential equation that passes through point 0 and 1. So 0 and 1 is right here, right? On the coordinate plane to the right. If we let s equals -1 and y equals 1/2, right? So we substitute over here. Does that mean we get 1 over 1, which is 1, right? So in order to draw a slope field right here, we need to go up by 1, go to the right by 1. So you're gonna get something like this, right? Similarly, if you have a point right here, s equals -1/2, you substitute over here, you have 1/2 over y equals, right here it could be 3/4, right? So substitute over here, you have 2 times 3/4. So it's going to be 1/2 over 3/2, right? So it's going to be 1/3, right? Now 1/3 is less than 1, so it could be less deep, so it could be something like this, right? So if you keep doing like that, you will have a possible solution curve to the differential equation, something like this. And the right hand side should be something like this. Alright, now let's move on to example number 2. Shown to the right is a slope field for which of the following differential equation. Again, you're going to use the Christmas tree trick. Alright, if you see the tangent line like this, the slope is positive. If you see the tangent line like this, the slope is negative. Remember, the bigger slope, the steeper. Remember, the smaller slope, the steeper. If the tangent lines going this way, the slope is 0. Tangent lines going this way, the slope is undefined. Keep that in mind. Alright. Now, here's a trick when you do the multiple choice questions. Pick a point with the 0 slope or undefined slope, right? So, right here, I'm going to pick this guy right here. Sit and sit, right? So, s and y equals sit, comma, sit, right? I substitute over here, and I know that this guy is horizontal line, right? So then the slope must be equal to 0, right? Now substitute over here, I get 12. I'm gonna eliminate this one, right? Substitute over here, it's gonna be 0, so this one could be right. Substitute over here, it's gonna be 0, this one could be right. Substitute over here, it's gonna be sit, right? So this one eliminated, right? Now I only have 2 slabs right here, right? So I'm gonna pick the next guy right here. Alright, so s equals 5, y equals 6, right? So then the slope is positive, right? Because it's going to be right here, right? S equals 5, y equals 6, it's going to be -1. The slope is negative, it's go over here. So this one is wrong, right? S equals 5, y equals 6, the slope is 1, which is right here, right? So the answer must be C. Now let's move on to example number 3. The graph to the right shows a slope field for the function y equals f of s. If the initial condition is 0, 6, what is the range of the solution curves y equals f of s for s greater than or equal to 0, right? Alright, now you're going to start from the initial condition. It's going to be 0, 6. So you have the point 0, 6 right here, right? So in order to sketch a slope field, you need to follow the flow. Alright, so you see that the flow is going to be something like this. Alright, observe that the domain should be s greater than or equal to 0, right? So you need to eliminate anything less than 0, right? Less than 0, which means on the left of the y-axis, right? So I need to eliminate this guy right here, right? So finally, your slope field graph should be like this. Now let's move on to example number 4. what is the general solution to the differential equation that generated the slope field to the right? Alright. Now, in order to do this question, you need to examine the graph of the slope field right here, and you need to follow the flows. Alright. Now, the best thing for you to do is to start from the origin, and you see that it's gonna pass the origin right here, right? And you know that the trigonometric function that passes the origin is the sine function, right? The cosine function starts from the maximum or the minimum, right? So you need to eliminate A, B, and C, right? You only have D, E left, right? And you know that the sine function is going to be something like this, right? Or y equal negative sine function is going to be something like this. Alright, so you look at this one, we just follow the flow. So it could be something like this. Alright, so the answer must be E. Now, example number 5, consider the differential equation dy over ds equals x squared times y minus 1. Describe all points in the xy plane for which the slope fields are positive, right? Now, in order to get the slope field to be positive, does that mean we get this one greater than 0, right? So, x squared times y minus 1 must be greater than 0. Now, you have two different cases. S squared greater than 0 and y minus 1 greater than 0, right? Or s squared less than 0 and y minus 1 less than 0, right? But this one is impossible. Why? Because s squared cannot be less than 0, right? So we need to eliminate this case, right? Now we're gonna focus on this one. S squared always greater than 0 except at s equals 0, right? So you need to write right here except s not equal to 0, right? Because s equals 0, when you square it, it could be 0, right? So this one is not a solution, right? Now to solve this one, does that mean you need to add one both sides, right? So you have y greater than 1, right? So you need to answer the question, all points in the xy plane for which the slopes are positive are s and y, where s not equal to 0 and y must be greater than 1, right? We're going to explore topic 7.5, how to use Euler method to approximate the particular solution to a differential equation dy over ds equals f of s and y, right? Because y prime is going to be dy over ds, right? So it could be f of s and y, right? Where y of s0 equals y0, right? It's going to be right here. Alright, now we have the formula yn plus 1, which is the next term, equals the previous term yn plus h times f of s and yn, right? Where h right here is called the step sign, right? And f of Sn, Yn is the derivative evaluated at the current point. Yn plus 1 approximates the value at the next S value. Alright, so let's take a look at the example right here. Example number 1. Use Euler methods to approximate the particular solution of the differential equation y prime equals s times y. passing through point 0, 1. Use a step size of h equals 0.2. Now question A, approximate y of 0.8. Alright, now first you need to put the initial points over here, right? X equals 0, y equals 1, right? Now this one right here is dy over dx equals s times y, right? Now, in order to calculate this column, you're going to take s times y is going to be 0, right? Now, you need to write equation of the tangent line. Remember, you have the point slope from formula y minus y1 equals m times s minus s1, right? Now, m, which is dy over dx right here, right? This is the slope. And s1 y1, which is this guy right here. Alright, so you have equation y minus 1 equals 0 times s minus 0, right? So if you simplify this one, it's going to be y equals 1, right? Now, since you have step size h equals 0.2, right? So you're going to keep adding 0.2 to the s column right here each times, right? So it's going to be 0.2, 0.4, 0.6, and 0.8. You're going to stop right here. Why? Because the question asks you to calculate y of 0.8, right? So this is where you stop. Alright. Now, you just got the new value y right here, right? So you put y over here. It's going to be 1, right? Now m equals dy over dx, which is s times y, so it could be 0.2, right? Now you have y minus y1, which is 1 right here, right? Equals the slope, which is 0.2 right here, times s minus s1 is right here. Alright, now I'm going to simplify this one, so it could be y equals 0.2 minus 0.04 plus 1. So it's going to be y equals 0.2 s plus 0.96, right? Now, in order to calculate the new y values right here, you need to substitute 0.4 for s into this equation right here to solve for y, right? So I'm going to add calculator right here. So I have 0.2 times 0.4, right? Plus 0.96, right? Hit enter. The answer is 1.04. So the value right here should be 1.04. Right? Now dy over dx equals s times y, right? So it's going to be 1.04 times 0.4, right? It's going to be 0.416, right? Alright, so you have y minus y1, which is minus 1.04 equals slope is going to be 0.416 times s minus s1, which means minus 0.4, right? Now I'm going to simplify this one, so it will be y equals 0.416 times s minus 0.4 at 1.04, right? So I'm going to substitute 0.6 for s into this equation to solve for y, right? So I'm going to bring up the calculator. So I have 0.416 right here, right? So I'm going to multiply by 0.6, subtract 0.4, which means 0.2, right? And then I'm going to add 1.04, right? And hit enter. The answer is 1.1232, right? So I have new y values 1.1232. Now I need to calculate dy over ds. So does that mean this guy times this guy, right? So I'm going to multiply by 0.6. The answer is 0.67392, right? So I have new equation y minus y1, which means 1.112 32 equals the slope 0.67392 times s minus s1, which means 0.6, right? So I'm going to simplify this one. So y equals 0.6792 times s minus 0.6 at 1.1232, right? So I need to calculate the new y value right here, given s equals 0.8, right? So I'm going to print up the calculator. So whatever I got right here, 0.7392, right? I need to multiply by 0.2, right? Because 0.8 subtract 0.6 is going to be 0.2. And then I'm going to add 1.1232, right? And hit enter. The answer is 1.25798, right? Alright, so you're going to stop right here. This is your answer. Now, question B, solve the differential equation dy over ds equals s times y with the condition y of 0 equals 1, then find the exact value of. Now, from this equation, I'm going to copy over here, so I have dy over ds equals s times y, right? Now, I need to separate these variables by dividing both sides by y and multiplying both sides by ds, right? So it's going to be dy over y equals s ds, right? Then I'm going to take antiderivative both sides, right? So it's going to be natural log of absolute value of y equals s squared over 2 plus c, right? Now I need to use the initial condition right here to solve for c, right? So s equals 0, y equals 1, right? So this guy turns out to be natural log of absolute value of 1 equals 0 squared over 2 plus c, right? Natural log of 1 equals 0, right? So this guy turns out to be c equals 0. Then the equation becomes natural log of absolute value of y equals s squared over 2 plus 0. I don't need to write, right? Now, since the initial condition right here positive, right? So then I just eliminate the absolute value side. So it could be natural log of y equals s squared over 2, right? Now I need to exponentiate both sides. So this guy turns out to be e raised to this one, e raised to this one, right? So it's going to be y equals e raised to the s squared over 2. This one is the final answer, right? Now, find the exact value of y of 0.8. So I have y of 0.8 equals e raised to the 0.8 squared over 2, right? So I'm going to bring up the calculator. I have e raised to the 0.8 squared over 2, right? Hit enter. The answer is 1.37713, right? Now let's move on to question C. The error in using Euler method is the difference between the exact value and the approximate value. What was the error in your answer? Alright, so you have error. So it's going to be exact value is right here. 1.37713. Subtract approximate value, which got right here. 1.25798. Right? So I'm going to print up the calculator. So I need to subtract 1.25798. Hit enter. The answer is 0.119148. Now, how could you produce a smaller error using the Euler's method? Alright, in order to produce a smaller error, we need to use smaller step size, right? We need to reduce the smaller step size right here. Right, the step size is 0.2. We need to reduce this one, right? So now let's move on to example number 2. Consider the differential equation dy over dx equals s minus y with the condition y of 0 equals 1. Use the Euler's method with 4 equal step size to approximate y of 2, right? So we're gonna sketch the table as we did in the example number 1, right? Alright, you given the initial condition x equals 0, y equals 1, so you're gonna put 0, 1 right here, right? Now you given 4 equals step size. Then s start from 0 and then end up with 2, right? So the difference between 0 and 2 is going to be 2, right? And then you divide by 4. So you have 2 subtract 0 divided by 4. So you have each step size is going to be 0.5, right? So you're going to add 0.5 each times, right? So the second one should be 0.5. The next one should be 1. The next one should be 1.5. And the last one should be 2 right here. This is what we need to find. It's going to be right here, right? Alright, dy over dx equals s minus y, right? S minus y is going to be negative 1, right? And then the equation of the tangent line is going to be y equals, the slope is right here, negative 1 times s minus s1, which means minus 0, right? Then you're going to add y1, which is 1, right? Remember, you have y minus y1 equals m times s minus s1, right? So I'm going to add y1 both sides, so it will be y equals m times s minus s1 plus y1. That's why I get this one right here, right? Now, I need to evaluate y of 0.5 to find the value right here, right? I substitute 0.5 for s into this equation, right? So does that mean I have y equals negative 1 times 0.5 minus 0 is going to be 0.5, right? Plus 1. So it's going to be negative 0.5 plus 1 is going to be 0.5, right? So I have 0.5 right here, right? Now dy over dx equals s minus y, so it's going to be 0 right here, right? So the equation becomes y equals, the slope equals 0 multiplied by this one is going to be 0, right? So I just add y1 both sides. y1 equals 0.5 right here, right? So it could be 0.5, right? Now I put 0.5 right here, right? No matter what values of s is, y is still the same, right? So s minus y is going to be 0.5 here, right? Then I have y equals, the slope is going to be 0.5 times s minus 1, right? At 0.5, right? So I substitute 1.5 for s into this equation. So I have y equals 0.5 times 1.5 minus 1 plus 0.5, right? 1.5 minus 1 is going to be 0.5. 0.5 times 0.5 is going to be 0.25 plus 0.5 is going to be 0.75, right? So I have 0.75 right here. Now dy over dx equals s minus y, so it's going to be 0.75, right? Alright, now I have the equation y equals, the slope is going to be 0.75 times s minus 1.5 plus y1, which means 0.75, right? So I substitute 2 for s into this one to solve for y, right? So I have y equals 0.75 times 2 minus 1.5, right? Plus 0.75, right? So I have 0.75 times 2 minus 1.5, which means 0.5, right? Plus 0.75. Hit enter. The answer is 1.125. And this one is the final answer. Now let's move on to example number 3. This one comes from AP Calculus BC 2021 free response question 5B. Let y equals fs be the particular solution to the differential equation dy over ds equals y times s natural log of s with the initial condition y of 1 equals 4. It can be shown that the second derivative of f of 1 equals 4. Now, use the Euler method starting from s equals 1 with two steps of equal sign to approximate f of 2. You're going to do exactly the same thing, right? You're going to sketch the table. Now, initial condition is right here, 1 and 4, right? So s equals 1, y equals 4, right? Now, two step size of equal sign, right? The final value should be 2, right? So this guy should be 1.5 and the last one should be 2, right? Why? Because the step size h equals 2, the final values, subtract the initial value, which means 1, right? Divide by 2 step size right here, right? So it could be 0.5, right? So you need to add 0.5 8 times, right? So it could be right here. Now, dy over ds, which is right here. Alright, so you have y times s times natural log of s, right? Natural log of 1 equals 0, right? 0 times s, it could be 0 times y is still 0, right? Now the equation should be y equals 0 times s minus 1 and 4. It could be 4, right? Now, no matter what value of s is, y is still 4, so I just put 4 right here, right? Same thing, I need to calculate dy over ds, right? So it could be y times s times natural log of s, right? So I have, now y times s, it could be 4 times 1.5, it could be 6, right? So it could be 6 natural log of 1.5, right? So the equation should be y equals 6 times natural log of 1.5 times s minus 1.5, right? Plus y, which is 4, right? Now I substitute 2 for s into this equation to solve for y, and this is my final answer, right? So it's gonna be y equals 6 times natural log of 1.5 times 2 subtract 1.5, which means 0.5, right? Plus 4, right? So I'm going to bring up the calculator. So I have 6 times 0.5, right? Times natural log of 1.5. Then I'm going to add 4. Hit enter. The answer is 5.2164. 5.2164. This one is the final answer. Now let's move on to question C. Find the particular solution y equals fs to the differential equation dy over ds equals y times s natural log of s with the initial condition f of 1 equals 4, right? So from this equation right here, I need to separate this variable, right? So you need to divide both sides by y and multiply both sides by ds. So it turns out to be dy over y equals s natural log of s ds, right? Then you need to take antiderivative both sides, right? So it can be natural log of absolute value of y equals. In order to calculate antiderivative of the right hand side, we need to use integration by parts, right? So remember we have L, I, A, T, E, right? Now L stands for natural log, right? So we have log right here. We need to let this one be u, right? So we let u equals natural log of s, then the u equals 1 over s ds, right? Now dv equals the remaining one, which is s times ds, right? Then we have v equals s squared over 2, right? So we have antiderivative of s natural log of s ds equals u times v, which is s squared over 2 times natural log of s minus antiderivative of v du, which is s squared over 2 times 1 over s ds, right? So this guy turns out to be 1/2 s squared natural log of s, right? Minus antiderivative of 1/2, I'm going to put in the front, right? So it's going to be s ds, right? So this guy turns out to be 1/2 s squared natural log of s minus 1/2 s squared over 2 plus c, right? So it could be 1/2 s squared natural log of s minus 1 over 4 s squared plus c, right? So I'm going to bring this one over here. I need to use initial condition right here to solve for c, right? So we have natural log of 4 equals 1/2 1 squared times natural log of 1 minus 1 over 4 times 1 squared plus c, right? So c equals, this one equals 0, right? Natural log of 4 plus 1 over 4, right? So the equation becomes natural log of absolute value of y equals 1/2 s squared natural log of s minus 1 over 4 s squared plus 1 over 4 plus natural log of 4, right? Now I need to solve for y, so I need to exponentiate both sides, right? So have e raised to this one equals e raised to the whole thing right here, right? So you have absolute value of y equals e raised to this one, right? Now since the initial condition is positive, right? So I can eliminate the absolute value side right here. One is the answer. Remember, the domain for this equation is s greater than 0 because you have natural log of s right here. Is defined when s greater than 0. Alright, so keep that in mind. Now, example number 4, AP Calculus BC 27, free response question number 5. Consider the differential equation dy over ds equals 3s plus 2y plus 1. Question A. Find the second derivative of this one, right? So, we have d squared y over ds squared equals. Now, we need to calculate derivative of this one with respect to s, right? So it could be 3, right? This guy turns out to be 2 dy over ds, right? This one is a constant, so it could be 0, right? Now, it's going to be 3 plus 2 times dy over ds equals the whole thing right here. So it could be 3s plus 2y plus 1, right? Now I need to distribute this one and I'm going to simplify it, right? So it turns out to be 6s plus 4y plus 5. This one is the final answer. Now question B. Find the values of the constant m, b, and r for which y equals ms plus b plus e raised to the rs is a solution to the differential equation. Alright, we have the differential equation is right here, right? So this one is the solution of this one. You're gonna check the derivative of this one first because we have dy over ds right here, look. Alright, so right here it turns out to be dy over ds equals, right? Take the derivative of this one with respect to s, so it could be m, right? Derivative of b equals 0, right? Derivative of e raised to the as plus b is going to be a times e raised to the as plus b, right? Remember you have e raised to the u, right? It's going to be u prime times e raised to the u. It's going to be like right here, right? So this guy turns out to be r times e raised to the rs, right? Now I substitute m plus this one right here for dy over ds back to this equation right here. So I have m plus r times e raised to the rs equals 3s plus 2y, but y equal this one right here, right? So I have ms plus b plus e raised to the rs plus 1, right? Now I need to distribute this one and I'm going to group them, right? So I have m plus r times e raised to the rs equals 3s plus 2ms plus 2b plus 2e raised to the rs plus 1. Now I need to group this one, so this guy turns out to be m plus r times e raised to the rs equals, look at this one right here, m is a constant, right? So the constant right here, 2b plus 1. So I have 2b plus 1, right? Now next one, r times e to the rs, so it will be right here, 2 times e raised to the rs, right? Now the last one right here, I need to factor s out, so it will be 3 plus 2m times s, right? Now look at the left side right here, I don't have s, so I put s right here, plus 0 times s, right? So I just equate the coefficient both sides to get a system of equations, right? Now this guy right here and this guy right here must be the same. So I have m equals 2b plus 1. Now the second one, r right here and 2 right here must be the same, right? So r equals 2. Now the last one, 0 right here and 3 plus 2m right here must be the same, right? So I have 3 plus 2m equals 0, right? Now from the third equation right here, I can solve for m, so m equals negative 3.5, right? I substitute back over here to solve for b, right? So I have 2b equals negative 1 plus negative 3.5 is going to be negative 5.5, right? So b equals negative 5 over 4, right? Now this one is the first case. Now the second case, what if r equals 0? Then I have the left hand side becomes m plus 0 times e raised to the 0 s plus 0 s equals, the right hand side is going to be 2b plus 1 plus 2 times e raised to the 0 s, right? Plus 3 plus 2m times s, right? Now the right hand side right here, observe that this one is a constant, right? So it could be 2. I'm going to add over here. So this guy turns out to be 2b plus 3, right? Plus 3 plus 2m times s, right? Now the left hand side becomes m plus 0 s, right? So I have a system of equation 2b plus 3 equals m, right? And 3 plus 2m equals 0, right? I need to solve for m and b, right? I substitute 2b plus 3 for m into the second equation. So I have 3 plus 2 times 2b plus 3 equals 0, right? So it turns out to be 4b equals negative 9, right? So b equals negative 9 over 4. Now I'm going to use the second equation right here to solve for m. So m equals negative 3 over 2. Right? And r equals 0. Right? So the second case, r equals 0, m equals negative 3 over 2, and b equals negative 9 over 4. The first case, you have r equals 2, m equals negative 3 over 2, and b equals negative 5 over 4. Now let's move on to question C. Let y equals f of s be a particular solution to the differential equation with the initial condition f of 0 equals negative 2. Use Euler's method solving s equals 0 with a step size of 1/2 to approximate f of 1. Right? So you're going to sketch the table, right? So you have s right here, y right here, dy over ds, right? And this one is the equation of the tangent line, right? Now, the initial condition is going to be 0 and negative 2, right? So x equals 0, y equals negative 2, right? The step side right here, h equals 0.5, right? And the final value is 1 right here, right? So you keep adding 0.5 until you get 1, right? So it could be 0.5 right here, right? Because 0 adds 0.5 is going to be 0.5. 0.5 adds 0.5 is going to be 1. We stop right here, right? Because we need to calculate this one right here. Alright, now I need to substitute 0 for s and negative 2 for y into this equation right here to solve for dy over ds, right? So this guy turns out to be negative 3, right? And the equation should be y equals, the slope is negative 3 times s minus s1 plus y1, which means negative 2, right? I need to substitute 0.5 for s into this equation to solve for new y, right? So it's going to be y equals negative 3 times 0.5, subtract 0 is going to be 0.5 minus 2, right? So negative 3 times 0.5 is going to be negative 1.5, subtract 2 is going to be negative 3.5, right? So it will be negative 3.5 right here. Alright, now dy over ds equals 3 times s, it could be 1.5, right? 2y, which means negative 7, right? Plus 1. It's going to be negative 4.5, right? Now y equals negative 4.5 times s minus 0.5, right? Minus 3.5, right? I substitute 1 for s, so it's going to be y equals negative 4.5 times 1 subtract 0.5 is going to be 0.5 subtract 3.5, right? So you have negative 0.5 times 0.5 subtract 3.5. Enter. The answer is negative 5.75. This one is the final answer. Now let's move on to question D. Let y equals g of s be another solution to the differential equation with the initial condition g of 0 equals k, where k is a constant. Euler's method starting from s equals 0 with a step size of 1 gives the approximation g of 1 equals 0. Find the value of k. Alright, so this problem we're going to do backwards, right? We need to find initial condition right here, right? So we just get a table, right? Now, s equals 0, y equals k, right? So we have 0, k here, right? Now, the step size is 1, right? And the final value should be 1, right? So I have 1 right here. dy over ds equals 3s plus 2y plus 1. So it could be 2k plus 1, right? Equation of the tangent line should be y equals, the slope is going to be 2k plus 1 times s minus s1. s1 equals 0, right? Plus y1 should be k, right? Now I change this one into g, so that I'm going to use this one easily right here, right? Now, substitute 1 for s into this equation. Does that mean I get g of 1, right? It's going to be 2k plus 1 times 1 minus 0 plus k, and this one equals 0 right here, right? Now I need to solve for k, right? So 1 minus 0 equals 1, right? So I have 2k plus k, it's going to be 3k plus 1 equals 0. K equals negative 1 over 3. This one is the final answer. Now let's move on to the last example. Example number 5 is similar to example number 1. I'm going to leave this one for you to practice. I just give you the answer key. We're going to explore topics 7.6 and 7.7. Solving differential equation using separation of variables. In this section, we will now solve a more general type of differential equation. The strategies we will use is rewriting the equation so that each variable occurs on only one side of the equation. This strategy is called separation of variables. Example number 1. Solve the differential equation y prime equals 2s over y. Alright, so y prime, we can rewrite this one as dy over ds equals 2s over y, right? Now we're going to bring y to the one side and s to the one side, right? So we're going to cross multiply. So this guy turns out to be y dy equals 2s ds, right? Now we're going to take antiderivative both sides. So we're going to put the integral side right here, right? Now antiderivative of y is going to be, now make sure you have this guy and this guy must be the same. This guy and this guy must be the same. So antiderivative of y should be y squared over 2 equals, antiderivative of this one should be 2 times s squared over 2. Don't forget to add a constant c, right? 2 and 2 right here cancel out, right? So I need to multiply both sides by 2. So I have y squared equals 2s squared plus 2 times c, which is another constant, right? So you just rewrite a constant c, right? Now take square root both sides, so it can be y equals plus and minus square root of 2s squared plus c. This one is the final answer, right? Now we're going to use the calculator to check our work, right? So you're going to bring up the calculator, hit calculate. Now you need to hit menu, calculus, scroll all the way down until you see differential equation solver right here. Now equation should be in this format, right? Y prime equals something, right? So you have y prime equals 2s over y, right? So you need to hit y, and then prime symbol should be this guy right here next to the boolean g. Alright, so you need to hit this one right here, prime equals 2s over y, right? So you hit 2s divided by y. Now independent variable should be s, dependent variable should be y. Now you don't have condition, so you just leave it plain, right? Hit OK and hit enter. The answer is right here, right? Y squared equals 2 times s squared plus c. Or you're gonna take square root both sides, you will get the answer, right? Now look at this table right here, original differential equation. Now s squared plus 3y times dy over ds equals 0. I need to subtract s squared both sides, right? So this guy turns out to be 3y times dy over ds equals negative s squared, right? Multiply both sides by ds, so does that mean I get 3y dy equals negative s squared ds, right? So you already successfully separated y and s, right? Y on the left, s on the right. Now, number 2 right here, sine s times y prime, which means sine s times dy over ds, right, equals cosine s, right? Now, you need to multiply both sides by ds, right? So I have get sine s dy equals cosine s ds, right? Then divide both sides by sine s, so dy equals cosine s divided by sine s ds. But cosine divided by sine it could be cotangent s, right? ds. That's why you get this one right here, right? Now the last one right here is gonna be s times dy over ds, right? Over e to the y plus 1 equals 2, right? Now you need to multiply both sides by e to the y plus 1, so it could be s dy over ds equals 2 times e to the y plus 1. Now you need to multiply both sides by ds, so it could be s dy equals 2 times e to the y plus 1 times ds, right? Now remember that dy and ds must be on the numerator, right? So you need to divide both sides by e to the y plus 1 and s, right? So this guy turns out to be dy divided by this guy is going to be e to the y plus 1 equals s go over here, it's going to be ds, right? So it can be 2 over s. That's why you get this one, right? Now, example number 2, solve the differential equation dy over ds equals 4s cubed over cosine y. Alright, so you need to separate the variables by cross multiplying this guy, right? So this guy turns out to be cosine y dy equals 4s cubed ds, right? Then you can take antiderivative both sides, right? So this guy turns out to be sine y equals, this guy is going to be 4s to the 4 over 4 plus c, right? So it could be sine y equals s to the 4 plus c, right? Now you need to solve for y, so you need to take inverse sine both sides, right? So I have sine inverse right here. So it's going to be y equals inverse sine of s to the 4 plus c. This one is the final answer. Now we're going to use the calculator to check our work, right? So you need to rewrite this one as y prime equals 4s cubed over cosine y. Alright, so you're going to bring up the calculator, hit menu, calculus, scroll all the way down, differential equation solver right here. So you need it y prime, right? So equals 4s cubed divided by cosine y. Alright, close parenthesis. Now, independent variable should be s, dependent variable should be y. There is no initial condition, so you leave this one plain. Hit OK. Hit enter. The answer is right here. Alright. Alright. Now we need to find the particular solutions. Example number 3. Given the differential equation s squared plus 4 dy over ds equals s times y. Find the particular solution determined by the initial condition y equal 2 and s equal -3. Alright, so we do exactly the same thing, right? We need to separate this one first, right? So I need to multiply both sides by ds first, right? So I have s squared plus 4 times dy equals s y ds, right? Now I need to divide both sides by this guy and this guy, right? So I have dy over y equals s over s squared plus 4 ds, right? Now I need to take antiderivative both sides, so it's going to be like this, right? So antiderivative of dy over y is going to be natural log of absolute value of y equals. Now antiderivative of this one, observe that we have formula u prime over u the yield equals natural log of absolute value of yield plus c, right? Now, if you take the derivative of the bottom, the top should be 2s, right? So, right here, I just multiply the top by 2 and then I need to divide by 2 right here, right? So then I can apply the formula right here, right? So it's going to be 1/2 natural log of absolute value of s squared plus 4 plus c, right? Now I need to use the initial condition right here to solve for constant c right here, right? So I have y equal 2, it's going to be natural log of 2. I don't need to put this one inside the absolute value side anymore. Why? Because it's positive, right? So it's going to be 1/2 times natural log of s1 and s3 substitute over here, it's going to be 13, right? So 13 is positive. I don't need to put this guy in the absolute value side anymore, right? So it will be 13 plus c, right? Alright, so c equals natural log of 2 minus 1/2 times natural log of 13, right? So then I substitute this guy back over here. So final solution should be natural log of absolute value of y equals 1/2 natural log of absolute value of s squared plus 4 plus natural log of 2 minus 1/2 natural log of 13, right? Now we need to simplify this one to solve for y. Alright, so you know that the initial condition right here is positive, right? So you can eliminate the absolute value side right here. So you have natural log of y equals 1/2 natural log of absolute value of s squared plus 4 plus natural log of 2 minus 1/2 natural log of 13, right? Now, in order to remove natural log, I need to exponentiate both sides, right? So, I have e raised to this one equals e raised to the whole thing right here, right? So, you know that e raised to the natural log of a is going to be a. Keep that in mind because you have e raised to the log base e of a equals a. Now this guy the same, it's going to be a, right? So this one turns out to be y equals. Now I need to apply the exponent rule. If I have a raised to the m plus n, it's going to be a raised to the m times a raised to the n, right? And a raised to the m minus n, it's going to be a raised to the m over a raised to the n, right? So this guy turns out to be e raised to the 1/2 natural log of absolute value of s squared plus 4, right? Now I have the plus side right here. It's going to be times e raised to the natural log of 2, right? And I have the minus side right here. It's going to be divided by e raised to the 1/2 natural log of 13, right? If I have k log base a of b, it's going to be log base a of b power of k, right? I can bring k back over here, right? So right here I can bring 1/2 over here, right? So then I'm going to apply the formula right here, right? So this guy turns out to be e raised to the natural log of absolute value of s squared plus 4, right? So does that mean I'm going to take the square root, right? Because s squared plus 4 raised to the 1/2 is going to be square root of s squared plus 4, right? And observe that s squared plus 4 always positive. So I don't need to put this guy inside the absolute value sign, right? Times e raised to the natural log of 2 over e raised to the natural log of square root of 13, right? I can apply this formula right here. Bring 1/2 back, right? And then it turns out to be square root of 13, right? Now, I'm going to apply this formula right here. It's going to be a, right? A in this expression is this guy right here, right? So this guy turns out to be y equals square root of s squared plus 4, right? Times, this one same thing. It's going to be 2, right? So I put 2 right here. Then I divide by square root of 13. This one is the final answer, right? Now we're going to use the calculator to check our work, right? So you're going to bring up the calculator. Now you hit menu, calculus, scroll all the way down until you see differential equation solver, right? Now the equation, you need to convert it one into this form right here, right? So I already converted. Y prime equals s times y divided by psi by s squared plus 4, right? So this guy turns out to be, now s times y, you need to hit s multiplied by y. If you only hit s, y, it doesn't work. So keep that in mind. Divide by parentheses s squared plus 4. Remember, don't forget the parentheses, so keep that in mind. Independent variable should be s, dependent variable should be y. Now you have initial condition you need to use right here. Y equal to s equal negative 3. You need to write this one in this form. Y of negative 3 equals 2, right? And then you hit OK, hit enter. The answer is right here. Alright, and you observe that it's slightly different from our answer. It's just because you need to radicalize square root of 13, right? So you just multiply the top and bottom by square root of 13, you will get this one, right? Now let's move on to example number 4. Given the initial condition y of 0 equals 1, find the particular solution of the equation s times y ds plus e to the negative s squared times y squared minus 1 dy equals 0, right? Now the first thing I need to do is to separate them, right? So in order to do that, I need to subtract this guy both sides, right? So I have e to the negative s squared times y squared minus 1 dy equals negative sy ds, right? Because dy always on the left hand side, keep that in mind, right? Now I need to divide both sides by this guy right here, right? So I have y squared minus 1 times dy equals negative s over e to the negative s squared ds. And then I need to divide both sides by y, right? So it could be like this, right? Now I need to take antiderivative both sides, right? So it could be like this, right? So I need to separate this guy, right? So y squared divided by y is going to be y minus 1 over y dy, right? Equals antiderivative of negative s over e to the negative s squared ds, right? Now, this guy turns out to be y squared over 2 minus natural log of absolute value of y, right? Equals this one right here. I need to use u substitution, right? So I let use b negative s squared. Then du equals negative 2s ds, right? So I look at this one right here. I don't see 2 right there. I need to multiply by 2, then divide by 2, right? So I have 1/2 right here, right? So this guy turns out to be antiderivative of the u, right? Because the u is equal to this one over e to the u. Now e to the u, I can write this one as e to the negative u right here, right? So this guy turns out to be y squared over 2 minus natural log of absolute value of y equals 1/2. Antiderivative of this one is going to be negative e to the negative u plus c, right? But u equals negative s squared, so it can be s squared, right? Now we need to solve for c. We need to use the initial condition right here, right? So s equals 0, y equals 1, right? So I have 1/2 minus natural log of 1 equals negative 1/2 e times s squared, but s equals 0, right? Plus c, right? So this guy turns out to be 1/2, right? Natural log of 1 equals 0, right? This one turns out to be negative 1/2 plus c. Then c equals 1, right? So the final solution should be y squared over 2 minus natural log of absolute value of y equals negative 1 half e to the s squared plus 1, right? Now we could simplify this one. Multiply both sides by 2. So I have y squared minus 2 natural log of y. Look at the initial condition right here. It's going to be positive, right? 1, positive. So I can eliminate absolute value sign, right? Equals negative e to the s squared plus 2, right? This one is the final answer. Now let's use the calculator to check out work. Alright, before you do that, you need to separate the variable and write this one in the form of y prime equals something, right? So I have dy over ds equals negative sy divided by e to the negative s squared times y squared minus 1, right? Now dy over ds actually y prime, right? So you're gonna bring up the calculator, hit menu, calculus, scroll down until you see d right here, right? So I have y prime equals negative s times y divided by parentheses e to the negative s squared close parentheses, then open parentheses one more times, y squared minus 1 close parentheses twice. Keep that in mind. Independent variable should be s, dependent variable should be y. Now you have initial condition right here, y of 0 equal 1, right? So right here you put y of 0 equals 1, right? Hit OK and hit enter. The answer is right here. Now let's move on to example number 5. Find the equation of the curve that passes through the point 1, 3 and has a slope of y over s squared at any points s and y. Be sure to say the domain of your solution equation. Since you have a slope of y equal s squared, it tells us that dy over ds equals y over s squared. You need to separate this variable by bringing ds over here and bringing y over here, right? So this guy turns out to be dy over y equals ds over s squared, right? Then you take antiderivative outside. So this is going to be like this, right? So antiderivative dy over y is going to be natural log of absolute value of y, right? Equals, this guy turns out to be negative 1 over s plus c, right? Now you need to use the initial condition right here to solve for c, right? So you have y equal 3, this could be natural log of 3. This guy is positive, so I can remove absolute value sign, right? Equals s1, 1, right? So it could be negative 1 plus c. So c equals natural log of 3 plus 1, right? Now, final solution should be natural log of absolute value of y equals negative 1 over s plus 1 plus natural log of 3, right? Now, to simplify this one, you need to exponentiate both sides, right? So I have e raised to this one equals e raised to this one, right? So it's going to be y, right? Because initial condition right here is positive, right? So you can remove absolute value sign. This guy turns out to be e raised to the negative 1 over s plus 1. And you have the plus side here, it's going to be multiplied by e raised to the natural log of 3, right? So this guy turns out to be y equals e raised to the negative 1 over s plus 1 times 3, right? Y equals 3 times e raised to the 1 minus 1 over s. This one is the final answer. Now we're going to bring up the calculator to check our work, right? So you have this one as dy over ds equals y over s squared. So it turns out to be y prime equals y over s squared. And initial condition is right here. Y of 1 equals 3, right? So you're going to hit menu, calculus, differential equation solver, right? So you have y prime equals y over s squared. Independent variable should be s, dependent variable should be y. Now initial condition should be y of 1 equals 3. And hit OK, hit enter. The answer is right here. We're going to explore topic 7.8 exponential models with differential equations. Alright, first we're going to talk about the growth and decay function. In many applications, the rate of change of the variable y is directly proportional to the value of y. If y is a function of time t, the proportion can be written as follows: dy over dt equals k times y. Now, exponential growth and decay model theorem. If y is a differentiable function of t such that y greater than 0 and y prime equals k times y for some constant k, then y equals c times e raised to the k times t, where c is the initial value of y, k is the proportionality constant. Exponential growth occurs when k greater than 0. Exponential decay occurs when k less than 0. Now we're going to prove this formula, okay? So we're going to start from here. So I have dy over dt equals k times y, right? Now I need to separate variable, right? So I see y right here and y is right here. I need to divide both sides by y and multiply both sides by dt, right? So this guy turns out to be dy divided by y equals k dt. Now I'm going to take antiderivative both sides. Alright, so this guy turns out to be natural log of absolute value of y equals kt plus c, right? Now I need to exponentiate both sides, right? So I have e raised to this one equals e raised to this one, right? So this guy turns out to be absolute value of y equals e raised to the k times t times e raised to the c1, right? Now we look at this one, y always positive, right? So you can eliminate absolute value side, right? So it turns out to be y equals e raised to the k times t, right? Now this guy right here I can set as constant c, right? So it could be c right here. And is proved right here, right? Now let's take a look at the first example. The rate of change of y is proportional to y. When t equals 0, y equals 2, you have the first order pair 0, 2, right? When t equals 2, y equals 4, you have the second order pair 2, 4. What is the value of y when t equals 3, right? So t equals 3 and y equals how much? We don't know, right? We need to find, right? Now we're going to use the formula y equals c times e raised to the k times t, right? Now we're going to use the first order pair here, 0, 2, right? So t equals 0, y equals 2. We have 2 equals c times e raised to the 0, right? Then c equals 2, right? Because e raised to the 0 equals 1, right? So then you have equation y equals 2 e raised to the k times t, right? Alright, now we need to solve for k. We're going to use the second order pair right here, 2, 4, right? So I have 2, comma 4. Then I substitute into this equation right here, right? So I have 4 equals 2 times e raised to the 2k, right? So then e raised to the 2k equals 2. Take natural log both sides, so I have natural log of e raised to the 2k equals natural log of 2, right? Bring 2k to the front. And then you have natural log of e equals natural log of 2, right? But natural log of e equals 1, right? So divide both sides by 2, so k equals 1 half natural log of 2. Then the equation becomes y equals 2 times e raised to the 1 half natural log of 2 times t, right? Now finally, you're going to use this one to solve for y, right? So given t equals 3, substitute over here. So you have y equals 2 times e raised to the 1 half natural log of 2 times 3, right? So it's going to be y equals 2 times e raised to the 3 and a half natural log of 2, right? Now you can bring 3 and a half back over here, right? So you have y equals 2 times e raised to the natural log of 2 raised to the 3 and a half. Now you know that e raised to the natural log of a equals a, right? So this guy turns out to be y equals 2 times 2 raised to the 3 and a half, right? So it's going to be 2 power of 5 and a half, right? Or y equals square root of 2 power 5, and it's going to be square root of 32, right? So it's going to be square root of 16 times 2, and it's going to be 4 root 2. This one is the final answer. Now let's move on to the next one, application of growth and decay. Half-lives. The half-lives of some common radioactive isotopes are as follows: uranium, carbon, arsenium, plutonium, cesium, nobelium. Activity in Chernobyl, USSR. Example number 2. Suppose that 15 grams of the cesium isotope CS-137 that was released during 1986 Chernobyl nuclear accident and absorbed into the groundwater. How long will it take for the 15 grams to decay to 1 gram and become safer to drink? Now, you need to summarize the problem. 15 grams that was released during 1986, so it tells us that you have the first order pair at t equals 0, you have 15 grams, right? 1986 is the initial time, which is t equals 0, right? Now, next one. How long will it take for 15 grams to decay 1 gram? Now, you know that this isotope is right here, right? Which means at 30 years, t equals 30, right? Then this guy right here, initial value right here becomes half, right? Half-lives, right? So it could be 7.5, right? Alright, now I need to use the order pair 0, 15 first. So I have the formula y equals c times e raised to the k times t, right? I need to solve for c first, so I substitute 0, 15 over here. So it will be 15 equals c times e to the 0, right? So c equals 15, right? So you have equation y equals 15 times e raised to the k times t, right? Now I need to use this order pair right here to solve for k, right? So I substitute this guy over here. Alright, so I have 7.5 equals 15 times e raised to the 30k, right? So then e raised to the 30k equals 1 half, right? Then I'm going to check natural log both sides. So I have natural log of e raised to the 30k equals natural log of 1 half, right? And then this guy becomes 30k equals natural log of 1 half, right? And k equals 1 over 30 times natural log of 1 half, right? So then you have equation y equals 15 times e raised to the 1 over 30 times natural log of 1 half times t, right? Now finally, we need to answer the question right here. How long will it take for the 15 grams to decay to 1 gram, right? So which means you have the order pair t, comma 1, right? Substitute over here, so you need to solve for t, right? So have 1 equals 15 times e raised to the 1 over 30 natural log of 1 half times t, right? I need to divide both sides by 15, so I have e raised to the 1 over 30 natural log of 1 half times t equals 1 over 15, right? Now take natural log both sides, so I have 1 over 30 times natural log of 1 half times t equals natural log of 1 over 15, right? Now I need to divide both sides by this guy. So it's going to be t equals natural log of 1 over 15 divided by 1 over 30 times natural log of 1 half. Then I'm going to hit the calculator, right? So you're going to add calculator. Then you hit enter. Now you need to convert this one to decimal. So you hit menu, number, convert to decimal. Hit enter. The answer is 117.207. Yes. Now let's move on to sample number 3. An absent-minded graduate student at a university is studying a population of fruit flies in a biology lab. She works under the premise that this experimental population of fruit flies increases according to the law of exponential growth. She counts 100 flies after the second day of the experiment and 300 flies after the fourth day. However, she forgot to record the number of fruit flies she initially had at the beginning of the experiment. Approximately how many flies were in the original population route to the nearest fly? Alright, so first you need to summarize the problem. Alright, so she counts 100 flies after the second day, which is you have the order pair 2, 100, right? Next, she counts 300 flies after the 4th day, so you have the second order pair 4, 300, right? She forgot to record the number of fruit flies she initially had, right? Which means 0, y, right? Now we need to use the first two order pairs right here to solve for c and k, right? Since you don't have the initial value, now you have equation y equals c times e raised to the k times t, right? Use the first order pair, you have the first equation. It's going to be 100 equals e raised to the 2k, right? The second order pair, 300 equal c times e raised to the 4k, right? Now I need to divide this one vertically, right? So take the bottom, divide the top. It turns out to be e raised to the 4k divided by e raised to the 2k, right? C and C cancel out, and it's going to be 3. Now I need to use exponent rules, so this guy turns out to be e raised to the 2k, right? 4k subtract 2k equals 2k equals 3. I need to take natural log both sides, so then you have natural log of e raised to the 2k equals natural log of 3. So 2k equals natural log of 3. K equals 1/2 times natural log of 3, right? Now I need to substitute this guy back over here to solve for c. So I have 100 equals c times e raised to the 2 times k, but k equals this one right here, times 1/2 natural log of 3. So 100 equals c times e raised to the natural log of 3, right? Now this guy turns out to be 100 equals c times 3, right? Because e raised to the natural log of 3 equals 3. Now c equals 100 divided by 3, right? So the equation should be y equals 100 divided by 3 times e raised to the k equals 1/2 natural log 3, right? Times t, right? Alright, now you need to solve for y when t equals 0, right? Substitute over here, so you have y equals 100 over 3 times e raised to the 1/2 natural log of 3 times 0, right? So y equals 100 over 3, right? Now if you want to convert this one to decimal, so it could be approximately 33.333 fruit flies. Now you need to round to the nearest fly, so it's going to be 33. Now let's move on to example number 4. 4 months after it stopped advertising, a manufacturing company noticed that its sales dropped from 100,000 units per month to 80,000 units per month. After the sales follow an exponential pattern of decline, what will they be to the nearest unit after another 2 months? Alright, so you need to summarize this problem. Alright, you have the first order pair, right? Initially, it's going to be 100,000, which is you have 0, 100,000, right? Now, 4 months later, so you have the second order pair, 4, 80,000, right? Lastly, what will they be to the nearest units after another 2 months? Which means t equals 6. You need to read the question carefully. Why, right? After another 2 months, right? So, now example 4 is slightly different from example number 3. Example number 4 is similar to example number 2, right? Because you have initial value right here. So you can solve for C directly. You don't have to use a system of equation like what you did in example number 3. So be careful, okay? So you have y equals c times e raised to the k times t, right? Substitute t and y, so it could be 100,000 equals c times e raised to the 0, right? So c equals 100,000. So you have equation y equals 100,000 times e raised to the k times t, right? Now you're going to use the second order pair right here to solve for k, right? So substitute over here. So you have 80,000 equals 100,000 times e raised to the 4 times k, right? Where t equals 4. Now you have e raised to the 4 times k equal 80,000 divided by 100,000, which is 4 over 5, right? Take natural log both sides, so you have natural log of e raised to the 4k equals natural log of 4 over 5, right? So you have 4k equals natural log of 4 over 5, right? So k equals 1 over 4 times natural log of 4 over 5, right? So the equation should be y equals 100,000 times e raised to the 1 over 4 natural log of 4 over 5 times t, right? Now, you're going to use this order pair to solve for y, right? So y equals 100,000 times e raised to the 1 over 4 natural log of 4 over 5 times 6, right? So right here I can write 6 over 4. Alright, now, so y equals, I'm going to use the calculator to calculate this one, right? So it could be 100,000 times e raised to the 6 over 4, which is 3 over 2, right? Times natural log 4 over 5. Then you hit enter. Convert this one to decimal. So hit menu, number, convert to decimal, hit enter. The answer is 71,554, right? Because you need to round to the nearest unit, right? Now let's move on to the next one. Newton's law of cooling. Newton's law of cooling states that the rate of change in the temperatures of an object, right here, is proportional to the difference between the object's temperatures and the temperatures of the surrounding medium. It's going to be right here, right? Where T0 represents the temperatures of the object and Te represents the temperatures of the surrounding environment. Example number 5. The world famous pastry chef Bernie Rose removes a completely baked cake from an oven and places a cooling rack in a room whose temperature is kept at a constant 60 degrees Fahrenheit. Using a cooking thermometer, he determines the cake cools from 100 degrees Fahrenheit to 90 degrees Fahrenheit in 10 minutes. The icing that is to be used for the cake cannot be applied until the cake's temperature reaches 80 degrees Fahrenheit. How much longer must Bernie wait to ice the cake? Alright, so you need to summarize this problem. Alright, you have the first order pair. He determines the cake cools from 100 degrees Fahrenheit, which means at T equals 0 is going to be 100 degrees, right? The second order pair is going to be T for 10 minutes, it could be 90 degrees Fahrenheit, right? Now the question asks you to find at what time T the temperature reaches 80 degrees Fahrenheit, right? Alright, so you're going to use the formula right here, right? So you have dt0 over dt equals k times t0 subtract te, right? Alright, but te right here is 60 right here, right? So you need to substitute 60 for te. Right, now you need to solve this differential equation by separation, right? So I'm going to separate this one first. So I have dt0, divide both sides by t0 minus 60, right? And multiply both sides by dt, so I have k dt, right? Now I need to take antiderivative both sides, right? So this guy turns out to be natural log of absolute value of t0, which means t object subtract 60 equals kt plus c, right? Now I need to use the order pair right here to solve for c, right? So t equals 0, this guy becomes 0, right? And 100 right here, which is t object, right? So I have natural log of absolute value of 100 subtract 60 equals c. So this could be natural log of 40 equals c, right? I have natural log of t0 minus 60 equals k times t plus natural log of 40, right? Now I need to use the second order pair, which is 10, 90 right here to solve for k, right? So at t equal 10, t0 equal 90, right? So I have natural log of absolute value of 90 subtract 60 equals 10k plus natural log of 40, right? So it could be natural log of 30, right? Subtract natural log of 40 equals 10k, right? So k equals natural log of 30 subtract 40, which means 30 divided by 40 is going to be 3 over 4, right? Divided by 10. Then the equation becomes natural log of t0 minus 60 equals k. I can rewrite this one as 1 over 10 natural log of 3 over 4, right? Times t plus natural log of 40, right? Now we're going to use the third order pair right here to solve for t, right? Natural log of t0 equals 80. So 80 subtract 60 is going to be 20 equals 1 over 10 natural log of 3 over 4 times t plus natural log of 40, right? Subtract natural log of 40 both sides, so you have 1 over 10 times natural log 3 over 4 times t equals natural log 20 subtract natural log 40 is going to be natural log of 20 divided by 40. So it could be natural log 1/2, right? So then t equals natural log 1/2 divided by 1 over 10 times natural log 3 over 4, right? So then this guy turns out to be 10 times natural log 1/2 divided by natural log 3 over 4, right? Now I'm going to bring up the calculator. So I'm going to hit 10 times parenthesis natural log 1/2, which means natural log of 0.5, right? Divided by natural log 3 4, which means natural log of 0.75, right? Then I hit enter. The answer is 24.094, right? Now let's move on to example number 6. Fish are being introduced into a man-made lake. The change in the rate of fish f with respect to time t is directly proportional to 900 minus f, where t is measured in years. When t equals 0, there are 400 fish in the lake, and 3 years later, there are 600 fish in the lake. Alright, now we need to summarize the problem. The change in the rate of fish f, which means df, with respect to time t, which means over dt, right, is directly proportional, which means equals k times 900 minus s, right? Alright, where t is measured in years. When t equals 0, there are 400 fish. You have the order pair 0, 400, right? 3 years later, which means at t equals 3 is going to be 600, right? So you already summarize the problem. Now write and solve the differential equation that describe this situation, right? So we have df over dt equals k times 900 minus f, right? Now you need to separate the variable first, right? So it's going to be df divide both sides by 900 minus f, and then multiply both sides by dt is going to be k dt, right? Then you're going to take anti-derivative both sides, so it will be like this, right? Now we need to solve this one. Remember, if you have anti-derivative of ds over s minus a, it's going to be natural log of absolute value of s minus a plus c, right? But this one is a minus f. F is the variable. Look at this guy, all right? This guy, all right? So it's going to be opposite, all right? So it turns out to be anti-derivative of ds over a minus s. It's going to be minus natural log of absolute value of a minus s plus c. All right, so keep that in mind. This guy turns out to be negative of natural log of absolute value of 900 minus f equals k times t plus c, right? Now we need to use the first order pair right here to solve for c, right? So we have negative natural log of 900 subtract 400 equals t equals 0, so this one equals 0, so it will be c, right? So c equals negative natural log of 500, right? So then I have the equation negative natural log of absolute value of 900 minus f equals kt minus natural log of 500. Alright, substitute into this equation right here. I get this one, right? Now I need to use the second order pair right here to solve for k, right? So I'm going to substitute over here. I have negative natural log of absolute value of 900 subtract 600 is going to be 300 equals t equals 3. So I have 3k minus natural log of 500. Now I'm going to add natural log of 500 both sides, right? So I have 3k equals natural log of 500 minus natural log of 300, right? So 3k equals natural log of 500 divided by 300 is going to be 5 over 3. So k equals 1/3 natural log of 5 over 3, right? So then I substitute this guy right here back to the equation right here. So I have negative natural log of absolute value of 900 minus f equals 1/3 natural log of 5 over 3. Now be careful, t is right here multiplied by natural log of 5 over 3. It's not 5 times t, so be careful, right? So you need to bring t to the front, right? So I can write this one as t over 3. And then I need to erase this one, right? To get rid of the mistake, right? Now I want to get rid of the negative side right here, so I need to multiply both sides by -1. So it turns out to be natural log of absolute value of 900 minus f equals natural log of 500 subtract t over 3 natural log of 5 over 3, right? Now I can bring t back over here, right? So this guy turns out to be natural log of absolute value of 900 minus f equals natural log of 500 minus natural log of 5 over 3 raised to the t over 3, right? Now it turns out to be natural of absolute value of 900 minus f equals natural of 500 divided by 5 over 3 raised to the t over 3, right? Now both sides have the same natural, right? You can equate this guy and this guy, right? So it could be 900 minus f inside the absolute value side equals 500. I need to bring this one to the top, so then I need to change the sign of the power. So it could be times 5 over 3 raised to the negative t over 3, right? Now observe that the number of fish is getting smaller and smaller as time increases, right? So then this guy always positive, right? So this guy turns out to be 900 minus f without the absolute value sign, right? It's going to be 500 times 5 over 3 raised to the negative t over 3, right? So then the equation becomes f equals 900 minus 500 times 5 over 3 raised to the negative t over 3. This one is the final answer for question A, right here, right? Now question B. Find the fish population in another 3 years, which is t in this situation is 6, and then f is unknown, so keep that in mind. Substitute 6 for t into this equation right here. You have f equals 900 minus 500 times 5 over 3 raised to the negative 6 over 3, which means negative 2, right? You can hit the calculator. It's going to be 900 subtract 500 times parenthesis 5 over 3 close parenthesis raised to the negative 2. Hit enter. The answer is 720. Now let's move on to question C. Find the limit of f of t when t approaches infinity and explain what the answer means. Alright, so we have limit f of t is right there. Now we can convert this one to positive exponent by rewriting this one as limit of 900, 500 multiplied by, you just flip the fraction right here, 3 over 5, and then this guy becomes positive exponent t over 3. Alright, remember if you have a over b power of negative s, this guy becomes b over a power of s, so keep that in mind. T approaches positive infinity. This guy right here approaches 0 because the numerator is less than the denominator, right? So it's going to be 900, right? Because 0 times this one equals 0. Now you need to say that the maximum number of fish that could inhabit the lake would be 900. We will explore topic 7.9 AB Calculus BC topic logistic models with differential equations. Logistic growth. In AB Calculus, the exponential growth model was derived from the fact that the rate of change of a variable is directly proportional to the value of y. When using the differential equation, dy over dx equals k times y, and its general solution y equals c times e raised to the kt. You may notice that the exponential growth is unlimited. However, when describing a population that often exceeds an upper limit L, past which growth cannot occur. This upper limit L is called the carrying capacity. It represents the maximum population y of t that can be sustained as time t increases. A model that depicts this type of growth is called a logistic differential equation. dy over dt equals k times y times 1 minus y over L, where k and L are positive constants. The logistic differential equation of the form dy over dt equals k times y times 1 minus y over L results in a solution of the form y equals L over 1 plus b times e raised to the negative k times t. Alright, so we have the formula logistic differential equation form is going to be this one, and logistic growth equation form is going to be this one. In either form, L represents the carrying capacity right here, L right here, and L right here should be the same, or upper limit of the logistic growth equation, which is the maximum. Alright, a logistic growth curve increases the fastest when the curve reaches half its carrying capacity L. Alright, let's take a look at the first example. The differential equation of a logistic growth model given by dy over dt equals k times y times 1 minus y over L has a solution of y equals L over 1 plus b times e raised to the negative k times t, right? Find the solution to the logistic growth model for the differential equation dy over dt equals 2 times y times 10 minus y with the initial condition y of 0 equals 1. Alright? So, first you need to write this one right here in this form. So how do we do that? We need to factor 10 out, right? Because we look at the formula right here, we see that this one is 1, this one is 10, right? So I have dy over dt equals, now factor 10 out, does that mean I have 20y, right? Times 1 minus y over 10, right? So then I can conclude that this one is L, right? Look, L right here equals 10. And from this equation right here, I can conclude that k equals 20. Right? Look at this one right here. ky, this is 20y, so k equals 20, right? So I substitute this guy over here. So I have y equals 10 over 1 plus b times e raised to the negative 20t, right? Now I need to use initial condition right here to solve for b, right? So I substitute this guy over here, right? So I have 1 equals 10 over 1 plus b times e raised to the negative 20 times 0, right? So this guy becomes e raised to the 0, it's going to be 1, right? So it's going to be 1 equals 10 over 1 plus b, right? So then 1 plus b equals 10 and b equals 9, right? So finally you have the answer. It's going to be y equals 10 over 1 plus 9 times e raised to the negative 20t, right? So the answer must be B right here. Now let's move on to example number 2. The number of phytoplankton specimens in a laboratory setting at time t is increasing according to the logistic growth model. which of the following statements could be true? Alright. So we need to identify the keyword. The keyword say the logistic growth model. Alright, so we're going to explore every single choice right here. Choice A. B of t equals 1780 over 1 plus e raised to the 0.035 t, right? Look at this one right here. Exponential is in the denominator, right? But this guy is positive, right? So if it's positive, it does not represent the growth model, right? So we need to exclude this one. Now, answer choice B. This one does not represent the growth model. It does represent the normal exponential growth, which is right here. Alright, so we're gonna exclude this one. Now, answer choice C. The second derivative of the function is positive. It tells us that the function is concave up, right? So it does not represent the growth model, right? We need to exclude this one. Now, answer choice D, we need to do backward, right? The logistic growth model is given by the formula right here. Alright, so we're gonna remove the antiderivative both sides. Right? So it's going to be dp over p times 1780 minus p equals 0.035 dt. I'm going to bring dt down and this one up over here. So it's going to be dp over dt, right? Equals 0.035 times p times 1780 minus p, right? Alright, I'm gonna factor 1780 out. So this guy turns out to be dp over dt equals 0.035 times 1780 times p times 1 minus p over 1780. Alright, this one actually the logistic growth model, right? It's going to be in this form, dy over dt equals k times y times 1 minus y over l, right? K equals this one right here. Alright, so the answer must be D. Now, let's take a look at example number 3. The spread of an infectious disease to workers on a large floor of an office building is modeled by the logistic equation P of t equals 800 over 1 plus 16 times e raised to the negative 0.5 times t, where t is the number of days and P of t represents the number of infected people. The graph of P of t is shown below. What is the number of infected people when the rate at which the disease is spreading is the greatest? Now, we're going to take a look at the notes right here. A logistic growth curve increases the fastest when the curve reaches half its carrying capacity. Carrying capacity is the value of L right here, right? So we're going to look at this one right here. Carrying capacity is 800, right? So you're going to take 800 divided by 2. You're going to get 400, right? So the answer is C, which is right here. 400, right? The maximum is right here. Now let's take a look at example number 4. The rate at which the natural gas is being extracted from an underground reserve at time t satisfies the differential equation dg over dt equals 0.04 g's times 1 minus g over 64, where g is measured in thousands of cubic feet and t is measured in weeks. For what value of g is the extraction rate increasing the fastest? Alright. Now example number 4 is similar to example number 3. Alright. So you're gonna say that the extraction rate is increasing the fastest when the model has reaches half its carrying capacity, right? Now this one is the carrying capacity by using the formula right here, right? L right here. Now before you're gonna use the formula, make sure you need to convert this one to this form, right? Make sure you have one right here. Right, so you observe that this one right here, you have one right here, so it's going to be exactly that form, right? So L equals 64. You're going to take L divided by 2. It's going to be 64 divided by 2. It's going to be 32. The answer must be B. Now let's take a look at example number 5. A conservation organization releases 30 pandas into a preserve. After 3 years, there are 50 pandas in the preserve. The preserve has a carrying capacity of 150. The growth rate of the panda population is dp over dt equal k times p times 1 minus p over l, which has a solution p equals l over 1 plus b times e raised to the negative k times t. Alright, so this one already in the original form, right? Now we need to summarize the problem. Alright, so from this one we have the first order pair is going to be at t equals 0, it's going to be 30 pandas released, right? The order pair should be t comma p, right? Now the second order pair is going to be right here after 3 years, which means t equals 3. You have 50 pandas, right? Now the carrying capacity is 150, which is L. 150, right? Now find L. L equals 150, right? Now question B. Find B. We're going to use order pair right here. Alright, so we're going to substitute this guy over here. So we have 30 equals 150 over 1 plus b times e raised to the negative k times 0, right? You always use the initial point right here, which means initial condition, to solve for b, right? So e raised to the 0 equals 1, right? So this guy turns out to be 30 equals 150 over 1 plus b, right? So 1 plus b equals 150 divided by 30. It's going to be 5, right? So b equals 4, right? Now let's move on to question C. Find the exact value of k. Do not write as a decimal. Alright, so we're going to substitute b back over here. And we're going to use the order pair right here, right? So we have the formula P equals L over 1 plus B times e raised to the negative k times t, right? Now, since we're going to use the order pair 3 commas 50, right? This one is t, this one is p, right? Now we have the carrying capacity L equals 150, right? Then we have B equals 4. We substitute the whole thing right here into this equation right here to solve for K, right? So I have 1 plus 4 times e raised to the negative 3k equals 150 divided by 50 is going to be 3, right? So then you have 4 times e raised to the negative 3k equals 2. Divide both sides by 4, so e raised to the negative 3k equals 1 half, right? Now take natural log both sides, so I have negative 3k equals natural log of 1 half, right? So k equals negative 1/3, natural log of 1 half, right? Or you can simplify this one, it's going to be negative 1/3 times natural log of 1 minus natural log of 2, right? So it could be natural log of 1 equals 0, right? So it could be 1/3 natural log of 2, right? Either this one or this one acceptable, right? Now question D. Write a model for a painter population in terms of t, right? So we have P of t, right? Substitute back over here, right here, equals 150 over 1 plus 4 times e raised to the negative 1/3 natural log of 2, all together multiplied by t. Now let's move on to question E. Use the model to estimate the painter population after 12 years. So we're going to use this one right here. So we have P of 12 equals 150 over 1 plus 4 times e raised to the negative 1 over 3 natural log of 2 times 12, right? Alright, now we're going to put this one on the calculator. We're going to hit add calculator. The answer is 120. Alright, let's move on to question F. Find the limit of the model as t approaches infinity. Alright, so we're going to copy this model over here. Alright, now we're going to take limit both sides when t approaches infinity. Now when t approaches infinity, this guy right here approaches 0, right? So this guy turns out to be 150 over 1 plus 4 times 0, right? So it could be 150. This one is the final answer. And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand in mine.